So this is your homework help video for your review worksheet that is being assigned to you guys from now on. Got 10 problems to do this week. What you guys are going to be working on this week is numbers 1 through 10. You could ignore this first sheet. That's unnecessary. But starts here on page 1 under practice exercises. You're going to do 1 through 10. Now I'm not going to do all of them just because I think that you guys know how to do quite a few of them. So for instance, I'm not going to do numbers 1, 2, or 3. All those 3 I think are pretty chill for you. I will give you a helpful hint for number 4. Now it's possible for you guys to do low-D high minus high-D low, but my suggestion, if you want to have an easier time, would be to rewrite it like this and instead go with a chain rule approach. So notice that I moved the 3 up to the top, made it negative, and now I would go with a chain rule approach. I think you'll find that a lot easier. I don't think you guys are going to need help with number 5. So number 6 is pretty interesting. Let's talk about number 6. We want to find the derivative of this one. So the first thing that you guys would probably do is change everything into the exponential form, right? That should be kind of habit by now. And then we're going to go ahead and apply the derivative rule here. So this is going to end up being x to the negative 1/2 and plus 1/4 x to the negative 3/2, right? From there, we're going to rewrite it. And here's where things get a little bit different, because that answer, as you guys can see, is not here, and yet it is. The reason why it's there is because they're simplifying even more. You guys see how that's x cubed, and this is actually is not uncommon. You sometimes can get an answer, but you need to simplify it more to get the right answer. So x cubed means we have 3 x's. Square roots take out pairs, so I could take out an x out of the square root there, as you guys can see. And so here's another way this answer could be written. And that answer is here. So this was kind of the trick on this one here, was that you had to simplify the square root at the end. They could have even gone further and made this even worse by getting a common denominator or something. So part of the issue with the multiple choices, after you've done what we already know how to do, it's not always in throwing your answer away right away. Sometimes it's going to be in just kind of manipulating it until you can find the one that matches. And what kind of triggered me to think about this one is the fact that this answer looked a heck of a lot like the answer that I had. It's just that I noticed instead of an x cubed here, they had x radical x, and I thought, oh, well, that's what happens if you take the cube root. So sometimes it goes with picking the answer that's closest, and then after that kind of going back and trying to manipulate it so it can turn out to be what you need it to be. Okay, so the next one we'll look at is number 7. Number 7 is really kind of weird. It's not hard per se, but it is weird. So first of all, what I want you guys to notice is that we want to find the derivative of this thing. And it's a chain rule, right? Because we have an inside function, which is this x squared plus 2x minus 1. And then we have the outside function, which is the square root. The first thing you're going to want to do is rewrite it as a power, right? And then we're going to do our chain rule. So the first thing you do is you move the half to the front, right? Don't change the inside. And take 1 off of the power. The next thing we're going to do is we're going to multiply by the derivative of the inside, which is 2x plus 2. Okay? Now this piece here is going to drop down to the bottom. Okay? So it's going to be y equals 1 over 2. That's this guy. And then this whole thing is going to be on the bottom because it's a negative power, right? And since it's a half power, it's a square root. And then on the top, we have 2x plus 2 being multiplied with the 1 there, which means it's really just 2x plus 2. and that's our derivative so far. Now I notice that answer is not there. Now there's quite a few answers that look pretty close, but right now we can rule out this because it's not 3 over 2. This one looks really weird. We know we should probably have a denominator in there somewhere. This one's pretty close. I don't know what's up with this one either. But let's go ahead and go a little bit further. Okay, so the first thing that we're going to have here is, notice on the top, I can factor out a 2. So the 2's go away. So now I've got an x plus 1 on the top, which means that's probably not the answer, which means we have this guy, which is an x plus 1 on the top, and this one too. But both of those are really weird answers. So what's up with that y? Well, what is y? Y is this, right? Do we have that in our answer anywhere? We do. We have it on the bottom. So I can replace that with y, which would give me y prime is equal to x plus 1 over y. And so it's this one. So I think that's a really weird question, but it's not weird in the sense that you wouldn't see that on an AP test. It's just weird that maybe you guys haven't seen a question like that before, where they just decided they're going to put the y back into it at the end, which is weird. But there you guys go. You got exposed to something a little new there. Let's take a look at another one. Number 8 is really straightforward. No secrets there. I'm going to go ahead and let you guys do that one. Let's go ahead and take a look at number 9. All right, so number 9, I'm going to show you guys an interesting little trick here. Now, you could solve this the way that you might be used to. The way you might be used to is to do a chain rule. So you have the inside function and the outside, and just do your derivative of the outside times the derivative of the inside. But I think you're going to find that to be really unpleasant, and there's going to be a whole lot of algebra to solve. But something that'll make life a little bit easier, not a whole lot easier, but a little bit easier, is if you guys remember a basic logarithm rule. Here it is. If you ever have log of a fraction, that's the same thing as ln of the top minus log of the bottom. You can rewrite it. And so that's what I'm going to suggest to you guys to do here on number 9. I'm going to suggest that we start by rewriting it like this. Ln of the top minus ln of the bottom. So why would I do that? Well, we had a rule about this that I shared with you guys on a FRQ video a little while back. Anytime you have ln of e, whatever that power is, that's what it simplifies to. Now, mind you, I'm not doing any derivatives right now. I'm just rewriting the expression. So first of all, I rewrote it using a log rule to look like this. Next, I used another log rule to change that to x. Now, I'm going to go ahead, now that I've rewritten the function to look like this, now I'm going to find my derivative. It's a little bit easier now. So y prime is going to be, the derivative of x is 1. The derivative of ln is going to be 1 over the inside multiplied by the derivative of the inside. The derivative of e to the x is just e to the x. The derivative of 1 is 0, so there's that. So this is what I have now. Now let's take a look. Do I have that answer anywhere? I don't. I don't have that answer yet. So we got to keep going. This one's close, but we know the derivative of x was 1, so that shouldn't be there. So let's keep going. Let's keep going here. Well, all the other answers you'll notice have only one fraction, which means maybe I need to combine these. And to do that, we need a common denominator. So instead of 1, I'm going to give it a common denominator e to the x minus 1. So what I did was I thought of this as 1 over 1, and I multiplied the top and the bottom by e to the x minus 1. And now this fraction and this fraction have the same denominator, and I combine. So if I can combine this with this, e to the x minus e to the x cancel out, and I'm left with a negative 1 over e to the x minus 1. And so there you go. Last one there, number 10. I'll help you guys out with that as well. Although I think you guys probably know how to do that. First of all, it might help you if you rewrite it a little bit instead of x over 2, think of it as 1/2 x, because that really means the same thing. Okay? Now the derivative of the outside is 1 over the inside squared plus, what was it? 1, wasn't it? All right. So that's that. Now we have to multiply that by the derivative of the inside. The derivative of the inside is 1/2. Right? So there's our arctangent derivative, and there's the derivative of the inside. So if I simplify this a little bit, I get x squared over 4 plus 1 times 1/2. Okay, well, that's not up there. But we know we could probably get rid of any of these options with square roots on them because there's no square root on the bottom. Notice that none of them are being multiplied by 1/2 either. So that means they probably want us to simplify that in. So let's do that. 1 times 1 is 1. And then let's distribute the 2 into here. So 2 times 1 is 2. And then 2 times x squared over 4, well, the 2 would go to the top. And that would be 2 over 4, which is going to be x squared over 2. So that's what I get if I multiply the bottom by 2. Okay, well, I do have one with a 2 there, but it's not x over 2. So notice none of them have the x squared being divided by anything. But we've talked about how you can get rid of that, right? What we've talked about in here is that you multiply everything by that bottom number. And so we end up with 2 over x squared plus 4. And there it is. Okay, so they wanted us to simplify that one. Darn multiple choices. They do want you sometimes to simplify. Okay, so that was it for this week. Hope that was a good review for derivatives for you. We're going to add some more next week. And any of these types of questions are fair game for the review portion of our next big test. Okay, so keep up with us. And I suggest you guys maybe print out these sheets as you go. Not the whole thing. There's like 26 pages here. But as we go, you know, print out the pages that we do. And keep them in your binder once I hand them back to you. It's a nice resource to have as a review.